This is a practice test on Unit 4, dealing with items from chapters 8, 9, and 10. And again, we'll follow or strongly suggest you use the protocol of pausing the tape frequently, reading the example, giving it a shot ahead of time, and then reviewing it as you continue listening and watching the video. Now, in this first example, deals with probability. We're going to draw two cards without replacement from a standard deck. What is the probability of choosing a king for a second card if the first card drawn without, and this is key here, without replacement was a jack? So the probability of picking a jack, now this is a little tricky because what they're asking here is you've already picked out the jack. It's not the probability of picking out a jack. You've already picked out the jack. Now, what's the probability that your next card is going to be a king and you're not replacing that? Well, there are now fewer cards in the deck. There's only 51 because you picked out a jack. So how many kings are there in a jack, in a deck? And the answer is 4. So your probability then for the second card, and again, you didn't replace any cards, is 4 out of 51. Now on this next one, we're asked to determine whether or not these events are dependent or independent. Jeff runs out of gas on the way to work. Jessica wins the state lottery. Are they connected in any way, or does one influence the other? No. So this would be independent. Now for question 3, we're going to take a look at this, which looks like compound interest. So just for practice, the formula is future amount, principal, 1 plus the rate, which is a percentage in decimal form. N is the number of times it's compounded during the year. And then we multiply it by the number of times compounded, and then times the number of years. So let's do some substitution. 5,000 is invested. Our rate is 7%, so that's 0.07. All over compounded monthly, so that'll be 12. And then it's going to be for 16 years. So this up here will be 12 times 16, which will give us an exponent. All right, we're going to put that in our calculator and see what we get. Now, for something like this, you need a protocol to put it carefully into your calculator. So my suggestion would be you start internally here and take 0.07 divided by 12. That's going to give you a long decimal, but then just add 1 to it, and that'll give you a value here. Then you're going to put a caret to put the exponent in, and 12 times 16 is 192. So it'd be caret 192. Get a value, don't round off. Then multiply this value by the 5,000. When I did so, I got this, 15,274.4866. That's what came up in my calculator. Now they want this rounded to 2 decimal places. So I went to the third decimal place, which was a 6. Dropped that, added 1 to the 8, and I get this as an answer. Item 4, we're asked to look at the following statements, and which is an example of classical probability. Now, classical or theoretical probability is when you figure something out mathematically, and that is your ideal type of probability. While the other, empirical probability, is you toss a cup and then see how many times it's going to land on its top, its side, or its bottom, and then use that data, let's say out of 100, to see what your probability would be. All right, so you're going to have to take a moment, read these carefully, and see which one you would pick. Well, the one that would be classical would be where you have a mathematical number like picking something out of a deck of cards. So it looks like this one. Now these others, you're collecting data, and from that data, you are working probability, and that is empirical probability. All right, let's go on. Now for item 5 here, we have this data, 1, 2, 3, 4, 5, 6, and we're asked to determine the mean. Well, the mean is the average. So one of the things, and there's going to be a number of steps for this, is to put your data in order. So we have a negative 12, a negative 12, a negative 12. We have 3 12s, and then we have a 14, a 14, and a 14. So if we add all of this up and then get a sum, and then divide that sum by 6 items of data, that will give us our mean. So take a moment. So when we add this up, we get a total of 6. So 6 divided by 6 is 1. So our mean is going to be 1. Now in part 2 of this question, they're asking, what is the median now? Well, we said once the data is in order from least to greatest, and if it's even, we have to go to our 2 middle terms, which is a negative 12 and a positive 14, and then take the average of those two. Well, the average of a negative 12 and 14 is 2 when we do this subtraction. So 2 over 2 equals 1. So our median then is 1. That is, in a sense, halfway through your data. So we'll put a 1 there and continue. I'll just continue here. Now, as we look at the data, we're wondering, is there a mode? Well, by definition, a mode is, once you have all your data, is there any item of data used more often than others? Well, the 12s are used 3 times, the negative 12s. The positive 14s are used 3 times. But there isn't one item of data that's used more often than others. So when that happens, it is no mode. Now, in order for this, just for review, if we had additional data here, and let me get a pen going here, and let's say we had a 17 and a 20. Now we don't, but if we did, then this would not be no mode, because now there are 3 negative 12s, and there are 3 positive 14s. This would have been a bimodal. That's not what they're asking here. We just answer depending on what is displayed. In this next example, we're asked to choose a student who is a physics major or a business major from nearby university to participate in a research study. Assume that each student has only one major. Now, would this be mutually exclusive or not mutually exclusive? Well, the physics major and a business major are quite different, and they only have one major, so these would be mutually exclusive. Now here we're looking at sets of letters, and again, for review purposes, let's make a Venn diagram. And this will be set A. This is the universe. And what is not in set A is considered a complement. So that's what we're asked to find here. Find a complement. So how do we do that? Well, I had suggested in our lessons that you take A and eliminate A from the universe. And then what's left in the universe is a complement. So we have an S, and I'll pause. You do it. You're going to cross out these from that. And then as you list the set, be sure to put it in braces, which you can get from your keypad, or you can get from your keyboard. All right. Okay, going over the strategy now. I've crossed out sympathize from our universe, and then what's not crossed out is the complement of A. And I had to use braces. I select it from my keypad up here, and then put commas between each one. Be sure they're commas as opposed to periods. And at the very end, I didn't put anything after the X, which was my last element. And that should be the answer. Now, I've seen students make errors on this by not putting in the braces, and then sometimes putting a period in there. I'd go in and give partial credit, but it's better to get full credit. Now, for this example, and what we're looking at is exponential functions here. And we said that in general, if we had the formula y equals a base to an exponent, if our base was greater than 1, you may recall, is going to have this shape, where if x is 0, this is 1. So it goes through 1 on the y-axis. So this is going through 1. So this is a possibility. Let's take a look at the others. This is not going through 1. And I'll take my dot off of there. That's confusing. That's not going through 1. Now, this is going through 1, but we said to get this kind of graph, and this is a review, we said it was y our base had to be a fraction, like 1/2. So this would be a fraction less than 1. And so that's not it. So interestingly, on this first one, bringing it back up, I will select this one. That's the one that matches. All right, let's go on. Now, this relates to probability. You're going to pause it and read it carefully. Here, a newspaper, customers by gender, their location of their residence, random, and our sample is this much. So our sample space here, they're giving us a total of 2116. Now, what is the probability that a customer is female? Express your answer as a fraction or a decimal rounded to 4 decimal places. Well, this one's pretty straightforward. I could have asked something a little bit more esoteric, but what we want to do is add up and see how many females there are out of our sample space. So take a moment, see what you get. So adding up the female column, I get 979. I did it twice. So 979 over our total sample space. Now they're not asking us to simplify, so I'm assuming I can put that in there as a regular fraction, 979, and not have to reduce it to 116. Now, if they counted that incorrect and you had the right proportion, just didn't reduce it, you'd get a lot of partial credit or maybe full credit, unless they ask specifically to simplify. All right, let's go on. Now, in this example, we're asked to describe the complement of the given event. Well, if this is your main event, 66% of 19-year-old males are at least this much in weight, then the complement of this would be, take a guess or know it, 34% of 19-year-old males are not at least this. That would be the complement. So if this were the main set, the complement would be what would be to make it 100%. That was easy as long as you knew the definitions. Okay, again, read this over carefully. You want to pick out the best Venn diagram that meets this above criteria. Okay, wetlands would be a subset of aquatic habitats. So this one, where wetlands are a subset of aquatic habitats. Let's go on. Here is another in which we are asked to find first the mean, then we're going to do the median, and then the mode. So again, a good strategy is put this in order. We have 1, 2, 3, 4, 5, 6, 7. So let's do that. Put them in order, and then we'll figure these out. So in adding these up, this is a -10, -11 here, and this is a +18. We get a total then of 7 divided by 7 items gives us a median here, mode of 1. Now if we go to our next slide, what is the median? Well, since there are 7, we just go to the middle one, which is the fourth one in. 1, 2, 3, 4 is also a 1. And sometimes these are easy. As we look at these, is there any number more than another? And yes, the 1s are repeated twice. So it's unimodal, and the mode is 1. It's kind of interesting how this is working out. All right, let's go on. Now, as we read this one, we're asked, find the number of outcomes in the complement of the given event. So again, a Venn diagram might help, but there's this many apartments. So our universe is 314. And this many are available for rent. So the complement of what would be this set available for rent would be those not available for rent, and you would subtract and would end up as 106.86. So that's what we're going to put here. As our complement. All right, let's go on. Here's another example of Venn diagrams. The universe consists of all cars. Select the Venn diagram that represents the following two sets: 2-door cars and 4-door cars. Take a moment. And actually, they are disjoint sets. They're separate. And this is the best example. Let's go on. All right, here we're going to have to read this carefully and find the probability. Now here we have a box that contain 6 green marbles and 14 white marbles. So what's our sample space? 6 plus 14 is 20. Now, if the first marble chosen was a white marble, and this one's a little tricky too, because they're not asking that you're first going to select a white. What's that probability? They're saying you have already picked a white. So, again, this is tricky. So if you've already selected a white, how many whites are left? Well, 13. And then since you're not replacing, how many marbles in the basket? 19. And there's the answer to this example. Now, again, I'm not going to try to confuse you by saying, but just to review, let's just do a little review. Suppose what would be the probability of picking out first a white? Well, then that would be 14 out of 20. And then picking out another white. That's not what they're asking here. They're saying you picked a white. So that's a given. Now there's one fewer white and one fewer in the basket. That's the question here. So you have to be careful what they're asking. Now, if it was first, what's the probability of picking a white? Then another white without replacement, it would be 14 over 20 and then 13 over 19. But that's not what they're asking here. So you need to be careful about that. So here they're asking us to write out the sample space. We're going to use B for boy and G for girls. And theoretically, you could make a little chart here, like we did in genetics there. So each time there's a boy or a girl, boy or girl. So you can have BB, GB, BG, GG. This would be our possible sample space for two children, and you're going to type it in. Notice the braces are already there. Separate your capital letters by commas. Now, keep in mind, do not put a comma after your last item. And in a sense, this could also be the idea of what's your sample space of flipping two coins, where heads and tails, and you would just change the letters to heads and tails, would be similar to this. In this example, we're asked to find the amount, the future amount, and note here in particular, it's continuous interest. So that formula is future amount is equal to P, Euler's Z, and then exponents rate times time. So take a moment to set this up. So our principal is 3150 Euler's Z, and then caret. You have to be careful. Some calculators include the caret, others you have to physically put it in. That's 0.05 times the number of years, 24. And let's see what you get. So I get $10,458. Now we're rounding it to 2 decimal places. So I go to the third decimal place, which is an 8, drop this, make the 6 a 7, and there's my answer. And we have another with continuous interest. And substitute. So that will be principal is 5225 Euler's E caret, and then it's 10%, so 0.1, put a 0 there, times 22 years. And let's see what you get. So carefully putting that into your calculator, and I get this. I go to the third place again. It's a 5. So I'm going to drop all this and add 1 to the 69 to make it a 70. Almost finished now. Now here we're asked to solve this logarithmic form for the x, which is the base. So putting it into an exponential form. Remember, let's have a little review here. So 2 to the third equals 8. Log base 2, the answer is 8, equals the exponent. Logs are exponents. So now we're going to convert this to its log form. Well, our base is x. Our answer is 49. And our exponent is 2. 49. Let's clean that up a little bit. All right, so what to the second power is 49? That's what you're going to put here. And if you said 7, I think you're going to be on the ball there. All right, let's go on. This is our last one. Now, solve the logarithmic function in terms of x. So using what we had before, I think we can bring that back as an example. Just erase this part here. So our base is 2. Our exponent is a negative 2. So what would x be? Well, this is going to be 1 over 2 to the second, which is 1/4. So here we're going to put in 1/4. And that'll be that. Okay, well, hopefully this worked out for you. And again, you're certified, practice certify, important skills, giving you the practice of using the software, honing your knowledge of these items.